This is lesson 1.5 in Algebra 1. We're solving or problem-solving plans using models. This is the things you actually do. We're just putting some logic to what you guys do and trying to organize everything. Goals: translating verbal phrases into algebraic expressions, and then we're going to use those in real-life problems. First definition is of modeling: writing an algebraic expression, equation, or inequalities to represent real-life situations. This is what's the most important part right here. It's the expression, equation, or inequalities to represent real-life situations. So 2 dogs plus 2 cats equals 4 animals. 2D plus 4C plus, that ain't what I said. 2D plus 2C equals 4A. That is a model of what I just said. A mathematical model is the expression, equation, or inequality that represents a real-life situation. Okay, so that is, the model itself was the 2D plus 2A plus 2C equals the 4A. That's the mathematical model itself. So the difference between those two: modeling is actually writing it, and the model itself is this part right here. It's what it actually is once you write it. Okay. Then we have a box we got to fill in. It talks about all those math keywords that you guys have been looking at for the last few years. It says addition is the sum of 6 and a number. So the sum, you know, that means to add. So 6 plus a number. 8 more than a number. Now, you know that this symbol means greater than. This is people get this a little bit confused when you start talking about more than and less than. You got to listen and you got to pay attention to what context it's in. Right here, 8 more than a number is just talking about addition, just plus. So it's not this one right here. But 5 or X is, no, you'll say greater than for that one. The less than is the one that confuses people. I'll show you that in a second. A number plus 5, so N plus 5. Again, you could use any variable right here, N plus 5. A number increased by 7, so X plus 7. Notice which one comes first in each of those. It says the sum of 6 and the number. 6 is first, and in the other 3, it's 8 more than a number. See, this is the one, and this is why I was talking about a minute ago, it being kind of confusing, because it's backwards. You see how the number 8 comes first, and in the model itself, 8 is second. When you use more than and less than, it confuses people because it goes backwards compared to the way it's written. Now, subtraction, on the other hand, the less than one is the one that people have the most problems with right here. 4 less than a number, because it's written backwards, just like 8 more than a number is written backwards. Notice the rest of them are all written in the order in the verbal model and in the mathematical model. The first one, the difference of 5 and a number. 5's first, and then the number second. So 5 minus that. 7 minus the number. 7's first, and then the variable second. A number decreased by 9. A number, again, that's the one you don't know, so N, decreased, subtracted by 9. Less than and more than, notice they're just written backwards. That's the one that people get confused with, because it's written backwards. Then multiplication is easy for most people. The product of 9, product means to multiply 9 and a number 9 times x. 10 times a number, notice 10 is first, 10x. And then a number multiplied by 3. Notice that one's backwards. A number multiplied by 3. And the only reason that one's written backwards is because it looks weird to write it like this. Y 3 like that. It still means y times 3. Just we've grown accustomed because of standard form of writing coefficients first. And then the last operation you look at is division. Quotient of a number in 4n over 4. And then 7 divided by a number. Notice the order is exactly the way it's written. 7's on top, divided by the number. Quotient of the number and 4n over 4. The first example says write an algebraic model based on what it says. You and your friends are going to a video store to buy DVDs on sale for $12.50 each. Together you buy 6 DVDs and you spend $79.50, which includes tax. Use mental math to solve the equation for how much tax you paid. Well, in the first box, we're going to put the total cost. And the reason we put in total cost first is because it says it's a box or a blank, and then it says equals. So we're looking for the total. We have the total. We can put it there, and we can solve for the rest of it. The cost per DVD is next, times the number of DVDs, plus the tax. So when we translate that verbal model into, when we label it, now this is what we can use for all of our labels. The total cost is $79.50. The cost per DVD is $12.50, and the number of DVDs is 6. So all that just comes right out of the problem itself. The tax is the unknown amount, T. Then when we convert that verbal model to an algebraic model, we're going to plug those values in. In place of total cost, we plug it in $79.50. In place of cost per, we put in $12.50. In place of the amount of DVDs we have, we put in 6, and then we have plus T. So all we have to do at that point is simplify. You know that you multiply before you add T. So it says $79.50 equals, when you multiply $12.50 and 6 together, you get 75 bucks. So right here, at this point, we're going to learn inverse operations very soon. But at this point, you can just say to yourself, 75 plus what number is $79.50, and that'll get you to the right spot to figure out how much tax or how much T is actually valued at, which is $4.50. You and your friends pay $4.50 in tax. Here's an example. Copy this one down. Go through all of the steps from example number 1 a second ago. So make a verbal model, then label it, and then make an algebraic model, and then use mental math. Take about 2 minutes or so. Okay, we didn't quite need 2 minutes for that one, everybody. I was getting that example confused with the one we just did a second ago. This is actually a little bit easier. All you're doing is taking each one of these and you're just translating them into algebraic expressions. It says 6 less than 4 times a number y. So 4 times a number y will look something like this, 4 times y. Then it says 6 less than that. Anytime you have that phrase less than, that's one of those tricky ones. It's written backwards. So instead of saying 6 minus 4y, it's 4y minus 6. That's how A should look, everybody. Remember that less than and that more than is written backwards. B says 3 more than the difference of 5 and a number n. So the difference of 5 and a number n. Difference is one of those words that means to subtract. So 5 minus n. 3 more than that means plus 3. Again, there's that term more than. More than and less than, it makes it backwards. So instead of saying 3 plus 5 minus n, you put the plus 3 after the 5 minus n. And then the last one says a number y decreased by the sum of 8 and the square of another number x. Got a lot to do in this one. It says a number y decreased by the sum of 8 and the square. So the sum, so let's look at just this part. The sum of 8 and the square of another number x. So we know that sum means plus. So 8 plus another number x, and the square of it means squared. So 8 plus x squared. And it says y is being decreased by that. So y is being decreased, so it's being subtracted by that. Now we have to add one more thing to this. In order to add 8, in order to sum 8 and the square of another number x, first, according to the order of operations, remember, this we have plus and minus on the same line, so we would do y minus 8 before we did 8 plus after we do the x, after we evaluate the x squared. But in order to do the addition first, we would have to do this. Now it's correct. Okay, here's a problem solving plan using models. It says ask yourself what you need to know to solve the problem. Then write a verbal model. So that's step one, verbal model. A lot of times you can write verbal models just with abbreviations and stuff like that. You don't have to write out long sentences. The next thing is label. So verbal model, then label. It's kind of like the scientific method. This is a problem solving method. Y'all learn the scientific method in your science class, or you should. Then the next one out is to write the algebraic model. Take the verbal model, and instead of having a bunch of words now, or even abbreviations, now just make variables and put your pluses, your minuses, and your subtract, your divisions and your multiplications in. Okay? And then the last step is to go ahead and solve it, and then, well, I should say the last step is to check it after you solve it. So model and answer the original question, and then check to see if it's reasonable. What it means by reasonable is if you work an equation or if you work a situation, let's say you're trying to find out that you're trying to find the amount of food that the cafeteria needs to feed a school or something like that. If you work it and you say they need 600 pounds of chicken, for example, that might sound like a lot, but when you have a school of 1,800 people, 600 pounds is not that much. You could say 6 million pounds of chicken. Now that's a little less reasonable for a school, but it's still considered a reasonable answer when you're talking about it on a scale of math. If you said negative 600 pounds, then that is not considered a reasonable answer anymore. It doesn't make sense to have a negative value, and that's what we'll see more examples that'll clarify that for you guys a little bit more. Those of y'all that are looking at me like, what do you mean? We'll clarify what I'm talking about exactly a little bit more later. It says you're running a marathon at a speed of 5 miles per hour. After 3 hours, you have run 15 miles. If you maintain your current speed, how long will it take you to run the last 11.2 miles of the marathon? It says use the formula time equals distance over rate to write a verbal model. So time equals distance over your speed. Remember, rate, I always tell you guys, rate is synonymous with speed. So rate over speed. Okay, so that's step one, verbal model. Step two is to label each of the things. A lot of times you can do this and you can label it in the problem itself. 5 miles per hour, that's your speed. You can do it that way, but let's see how it looks here. When you label it like that, the distance, your speed is 5 miles per hour. The distance is 11.2, so that's the labeling step. The next step is to take the verbal model and use those labels and create the algebraic model. So now instead of saying time, you put in t. Instead of saying distance, you put in 11.2. Instead of saying your speed, you put in 5. Then when you simplify this, 11.2 divided by 5, you get 2.24. And then so we solved it to get 2.24 and then check to see if it's reasonable. If you maintain your current speed, it'll take you 2.24 hours. Does 2.24 hours make sense? Yes, that's a number that makes sense in order for you to finish the marathon. Okay, here's example number 1 on the checkpoint. It says in example 2, is it reasonable to expect that you can finish the entire marathon in 5 hours running 5 miles per hour? So let's see what that means. Okay, you want to write a verbal model first. So your verbal model would say, remember, let's use the exact same one we used a second ago. Time equals distance over your speed. Okay, so time equals distance over speed. Again, that's what I meant by abbreviating stuff like that. Time equals distance over speed. Is it reasonable to expect to finish it in 5 hours running 5 miles per hour? Well, let's look and see. Let's label everything. The second step is to label everything. Entire marathon. That's the one we're going to leave. We're going to leave by itself for a second. We'll talk about that one in a second. It says 5 hours. That's going to be our time. So time is going to be 5 hours. 5 miles per hour. That's going to be your speed or your rate. So we have, in place of time, we're putting in 5 hours equals, in place of speed or rate, we're putting in 5, and it's miles per hour. So we had 5 hours here, 5 miles per hour. Now the distance of an entire marathon is what's not given right there. The distance of an entire marathon. You have to understand, and you have to learn this, that an entire marathon is 26.2 miles. I'm sure everybody in here has heard that figure once upon a time. You probably forgot it. or you probably don't remember it exactly. Some of y'all might have parents or people that you know that have run marathons. But it's asking to say, if you divide 26.2 by 5, is it reasonable to see that you can run it in 5 hours? Is this a true statement? This is what we're talking about. Is it a true statement? No, because when you divide 26.2 by 5, you don't get 5. You would have to divide the number 25 by 5 in order to get 5. 26.2 in 5, if you're going only 5 miles an hour, you will not finish it in 5 hours. It's going to take you longer. Example number 2 says the Science Club is selling magazine subscriptions at $12 each. How many subscriptions does the club have to sell to raise $276? Use the problem-solving plan. So the first thing we want to do is we want to write a verbal model. Okay, so our verbal model is going to say, let's look and see everything we need. It says selling magazines at $12 each. How many do they need to sell to raise $276? So let's call the first one the goal. So goal money equals each magazine. So each magazine times the number of magazines. And we did something like this yesterday when we did that Statue of Liberty problem and when we did that lockers problem. It's really similar to this. So we've done stuff like this already. That's the verbal model. Again, this is just the problem-solving method. Okay. The next one is to label everything. Now, instead of writing an entire step of labels, do like I do all the time. Just go inside the problem and say $12 each. That's going to be the cost. We called it each magazine. So each magazine. Our goal money is $276. So that's our goal. So now we have it labeled. It says how many subscriptions. So how many subscriptions would be the unknown amount. So if we take all of those things and we plug them in to make the algebraic model, in place of the goal money, you're going to plug in $276. This is the algebraic model. Equals each magazine, we're going to make $12 from it. And then the number of magazines is going to be unknown. So let's say for subscriptions, let's call that S. So now we have 12 times S is equal to 276. So 12 times what number is 276? Well, 12 goes into 27 2 times, and 46 is left over. So you're going to need almost 4. So to be 23 is what it's going into. So there are 23. Again, we're looking at the mental part of this. We haven't talked about inverse operations to make this make sense yet.